Alright, 7.4a is what's next. Radicals can be written using their exponents. What I mean is, remember if we say power over root, when you see numbers like this, the power would be 1 for all of these. And the root, well then there's no root, there's a 2 there, but the root is 3, the root is 4. So I can rewrite this as 25 to the 1/2 power. Alright, we've talked about this before, which then again, of course, is 5, whether you write it either way. So of course this is 27 to the 1/3 power, okay, which of course the cube root of that is 3. This would be 16 to the 1/4 power. The answer is not 4 because it's not square root, it's 4th root, and that answer is 2. So in general, a to the 1 over n is a to the 1st power, and the nth root, again, power over root. We've done that before over and over and over. Let's write it down. Power over root. Okay. Now, how can we write these? Well, so you want to find out what the simplest way is, and oftentimes this is not the simplest way. The nth root of a to the m power, because again it's power over root, right? Oh, there it is again. So you could take the power of a number and then try and find the root of that. Oftentimes that's much harder because you're going to get a huge number and then try and figure out whatever nth root of that is. It might be a lot easier if we take the nth root of a first, take the nth root of a big number, and then take that to a power that we can figure out how to do. So again, there's two ways to do it. Okay, I'm going to do the first two real simply. This again is power over root. So this is x to the 3rd power and the 5th root. We can write it like that. Or we can take the 5th root and take that to the 3rd power. It's going to make more sense as we keep going, but that's how it works. Now when it's negative, remember what makes a negative exponent positive is by flipping it. So this is really over 1. So really this is y over, or 1 over, excuse me, y to the 2/5 power, which is 1 over power over root, or 1 over take the power and then root it. Okay, those are my two answers there. You have two to kind of try on your own. Make sure you understand which one goes where in number 3 and number 4. So press pause a second, try those two problems out. There you go, simple as that. Make sure you check your answer. In the next couple of problems, let's write this radical in exponential form. So again, when there's nothing here, then remember that means a 2, and it's x to the power over root. And it really is that simple. Okay, this is y to the power over root. Done. This is x to the power over root. This is y to the, try it. Make sure you try it. Again, when there's nothing there, it means 2, so it's 3 over 2. Okay. Looks different than that, same answer. Okay. Alright, so to simplify these problems at the bottom, we are going to use power over root. So in this problem, I have 125 to the 1st power in the cube root. I would say I'd probably do it to the 1st power first, which is 125, and then the cube root of that, well that's just 5. What about this one? Well, this is 1 over 9 to the power over root. So here's the thing. 9 to the 3rd power is 729. Do you know the square root of 729? Probably not. So this might be easier to take the square root first and then cube it. Because the square root of 9, of course, is 3. And 3 cubed is pretty easy. It's 27. Simple as that. Okay. Let's try 11 here. Negative is in the number, not the exponent. So this is negative 32 to the 5th root and the 3rd power. Now, I don't know negative 32 to the 3rd power. I think 32 to the 2nd power is 964 if I'm doing the math right. But to the 3rd power is crazy. But maybe I can take the 5th root of that. And I can. It's negative 2 to the 3rd power means negative 2 times negative 2 times negative 2. So it's going to be a negative 8. Try 12 through 15. Come back and check your answers. There you are. The fourth root of 16 is 2. 1 over, because again it's negative, the square root of 25 cubed. 5 cubed is 125. The fifth root of 32 is 2 to the fourth power is 16. And the fourth root of 81 is 3 to the third power is 27. If you are doing the opposite, let's say you did a 3 here and a 4 here, it's not going to work out so pretty. And these numbers generally are. I'm not trying to make this terribly difficult. Okay, so make sure that works out. Let's go on to the next page, which is the 7 for B notes. Okay, so going back to the idea again of power over root. Okay, make the problems easier on yourself. Sometimes it's easier to take the root than the power, sometimes the power than the root. We saw that on the previous page. First things first, I just want to talk about how we simplify these things. When we have the same base, that means we add the exponents. Okay, so more than one base, add the exponents. And 1/2 plus 1/2, of course, is 2 halves. And 5 to the first power is just 5. Of course it is. 1/2 power we know means square root of 5 and square root of 5. If I multiply those, I get square root of 25, which gets me to 5. So again, writing it as a root may be easier sometimes. Like for the next one, they don't have the same base, so I can't just add the exponents. But this means cube root of 10. This means cube root of 100. And we know now we can multiply those through and get our answer. Okay? You try 3 and 4. Press pause, try 3 and 4. Okay. Check your answers there. Should be pretty straightforward. Just got to remember this time they are actually asking for square root, not fourth root. Down below, each one of these problems is probably one that I would ask for your help with, but generally have you doing on your own. This would be 8 to same base, add the exponents. It's getting kind of tedious because we're getting the same answer here. That would give me 1, and 8 to the first power, of course, is 8. Power to a power. Okay, so if I have x to the n to the m power, means I have to multiply those exponents. When I have 2 bases up here, I add the exponent. When I have 1 base, though, I multiply. And 5 to the 1/2 times 4, well, half of 4 is 2. And of course, that gives me 25. This gets distributed powers. So this is 4 to the 1/2 power, x to the 1/2 power. If you remember, 1/2 power means square root, so square root of 4 gives me 2. Square root of x just gives me that. If you wrote that as 2x to the 1/2, it's the same thing. I would accept that as well. Okay? Over here, I've got, again, same base. So I need to subtract because it's divide with the exponents, which gives me 10 to the 2/2, which gives me 10 to the 1, which of course is just 10. Okay. Let's keep going here. 9. I would distribute this through. 1/3 means power over root. So this is cube root of 5 over cube root of 27. Now we know we can't have radicals on the bottom, and that's okay because the cube root of 27 is just 3. Can I have them on top? Yup. We're going to leave it like that. This one's a little more difficult. We're not taking to the 4 to the negative third power and then 4 to the half. This we would have to do, if you don't remember, something called the merry-go-round, where we times these and we add those. And I don't even look at the negative, because if I do, I'm going to get negative 5 over 2, which is negative 2.5, not negative 3.5. 2 times 3 is 6, plus 1 is 7. This is 4 to the negative 7 over 2. Now again, that is power over root. The square root of 4, 1 over, because it's negative, to the 7th power, which is 1 over 2 to the 7th power, which is 1 over 2, 4, 8, 16, 32, 64, 128. What I want you to keep in mind is anytime it's a negative exponent, it doesn't make the number negative, it just makes it small. Negative times a negative here, not there though. This is going to be 16 to the negative 3/4 times y to the negative 8 over 1 times negative 3 over 4, which is 1 over the 4th root of 16 cubed times y to the, well, negative 24, positive 24 over 4 is 6. Okay, so that's kind of over 1 really. Or I could just remember that negative exponents to pull it down here. So here I'm going to get y to the 6th over 2 to the 3rd, which is y to the 6th over 8. A lot of stuff going on in that problem. Okay. Distribute here, 8 to the cube root and square it. x to the 15 over 1 times 2 over 3. Again, that's how we multiply fractions across, remember. This becomes 2 squared x to the 30 over 3, which is 4x to the 10th. And I'm done. Okay? That is the note for 7-4A and 7-4B. Your homework then would be the next 2 pages, 1 through 23. Actually, I'll probably, again, take some problems off of here, so make sure you're double checking Google Classroom to see the assignment. Same thing with the back page, 7-4B, I probably will take a few problems off of here as well. Make sure you're paying attention to Google Classroom. Have a good day.